Here are some tips and advice for doing programming, both in general and specific to Jupyter notebooks. One of the general pieces of advice that I would like to give you about programming is that you really want to make sure that you understand what your code is doing. It will often be the case that you're drawing on some example or you're kind of following a familiar structure that's been shown to you, but it's really critical that you know what that piece of code is actually doing and why it's doing it. What would happen if you changed one of the pieces of it? Which parts are keywords that can't be changed? What is an alternate approach that you could use to do the same thing? These are all great questions that you should ask yourself either after a problem is solved or while you're having trouble with a piece of code. Because if the code doesn't come up with the result that you think it should, you're not going to be able to debug it and figure out a fix for it if you don't understand what the different pieces of it are. An example of this is many of the for loops that you'll see shown to you in Python have a loop variable like I, where it says for I in range 100 or something like that. Often the I is unused in some of those basic starter examples that you've been shown, but sometimes it is being used, and it's important to understand the difference between those two situations. What would happen if you changed the name of that variable, what you're doing with that variable inside of the loop, and what the range is actually causing to happen. Range is another great example of this. If you don't understand that ranges go from their start inclusive but are exclusive of the end number. For instance, when I said range 100, the number 100 would never come out of that range. Then, if you don't understand that, then you're going to get things wrong with what you're actually trying to do with those for loops or with those ranges. So, even once you've finished a problem or while you're debugging it, trying to understand exactly what your code is doing. There are, in some programming settings, debuggers that will let you step line by line through your code as it executes. We may look at some of those at a later point, or you might look at one next semester if you take 256. But there are also ways that you could, for instance, print out things inside your code to see what's changing and what's going on as it executes. When you're given a specification, it's important to follow exactly what's specified, not to do more than what's specified, because that might cause side effects that aren't expected in later code or that aren't expected by the tests, for instance, when you're submitting code for an assignment. And it's also usually very important not to do less than what's specified. So, for example, if something says to convert your input all to lowercase and then do some process on it, if you fail to convert your input to lowercase, then you're going to get some wrong results sometimes. It may often appear that your code works perfectly for the tests that you try or the tests that you're able to see for the code. But again, especially in larger projects, if you're using a piece of code for later stuff, it may well be the case that you hit some situation where the input that was given to you is not properly handled by your code, or that your code hits the case where the math was off. An example of this is if you are told to not allow division by 0, then it's important that you actually make sure that your code's not about to divide by 0, because you might forget to try a test where 0 is given as an input or where 0 is a possible situation there, and your code looks like it's fine until a user goes and gives you the value 0, and your code allows division by it, and then the program blows up because you're not allowed to divide by 0. it's absolutely fine to ask for clarification on the specification. If it seems ambiguous to you, there may just be some terminology you don't understand, or there may be an earlier piece of it that you forgot or that you didn't notice. Or it may be actually the case that the specification is ambiguous. When I've done contract work for people, have quite often got specifications that were very ambiguous, and I've had to do a lot of work and spend a lot of time getting clarification on those, because it's important that you know exactly what the specification is that's needed so that your code can handle all of the cases that are required, can behave smoothly in all of the situations that might be presented to it, and so on. Many of the testing tools will rely on your code having fully met the specification. And again, it's just a general good practice. If there's been a specification agreed upon, that's what your code should do. As we get deeper and deeper into functions in particular, it becomes more and more important that the functions you've written do exactly the job that they were specified to do. Because if you write a function, what you should be able to do is write a function, have it solidly do the job that you expected it to do and that you've agreed with anyone else who's sharing the code with you, for instance, coworkers who you're working on the same project with, or yourself at a later point when you have to reuse that code. You have agreed that it meets a certain specification. You should test it very thoroughly and make sure that it does meet that specification. And then you should be able to move on and rely on the fact that it's going to do its job. You do this with functions from the Python libraries already. You rely on the fact that print will do its job, that there won't be any weird situation where you give it the letter capital S and somehow it wasn't written properly to handle the letter capital S. And so your functions should behave just as reliably. They're given they have a specification, whether it was given to you or whether you come up with it, and they should meet that specification and be reliable from that point onward. A lot of people want to partially solve a problem and then move on and dig into more, and that is okay if you're tracking which tasks are left to do, but it's not okay if you just assume that partially solving it is enough and never come back to it. And it will be a lot harder to write those later pieces that rely on that piece of code, for example, that function. You'll have errors in them that now you can't tell if that error is from your new code or if it's from that earlier code that you didn't really bother to get thoroughly tested and properly behaving. In that same vein, it's important that you validate your code. So validation is another word for testing. There are lots of ways to test your code, but in Jupyter, we have the feature to be able to validate your code. It will run all of the blocks of code that are in your notebook, in your page there, and it will tell you whether there were any errors. Now, errors have a pretty specific meaning in Python. They're also sometimes called exceptions in other programming languages. And these are very explicit things where either your code is so wrong that it cannot even be read by the Python system to be run. That's usually referred to as a syntax error. For example, 5 equals x. Python cannot set the number 5 to be equal to anything but the number 5. And so that is an error in the way you wrote your program, an error in your syntax. So that's one kind of error. Other errors are like the kind that you saw put into Lab 1 already for you, where it says, raise not implemented error. And there are other types of errors that can be created as your code runs. For example, if you try to divide by 0, that can raise errors. If you try to look something up that doesn't already exist, like a variable name that wasn't already defined, that can raise errors. So there are lots of errors that can happen as your code runs. These are also referred to as runtime errors. So syntax errors are problems with the syntax, the way you wrote the program, the words and the order of things. And exceptions or runtime errors are things that happen as your program is running, that just are kind of problems with the state of things. Something wasn't implemented, you tried to look up something that doesn't exist, different things like that. Nothing really wrong with the words that you wrote or the variables that you wrote necessarily. They're all valid variable names and legal statements in the language, but something went wrong with the way the program was running. So those are the two kinds that validation will find for you. What validation will not usually find for you is if there are logical errors in your program. For example, your program was supposed to print out 5 things, but it only printed 4 of them. Validation will typically not catch that. Likewise, in some cases, if your program was supposed to, or if your function was supposed to return 0, in certain cases, the validation may not catch that. Our grading might catch that, and then you would lose points even though your program showed up properly in validation, because it may be a valid program, and that's mostly what validation is testing, is sort of does it run? Does it meet some very basic criteria? Not necessarily does it run in the exact way we're expecting. Another example of a case where validation might show up properly or might say things are running properly, but you might lose points, is if we said to use a loop to print out or to add up the first 5 integers. Your code might return the right value in the case of adding up the first 5 integers. It might return the right value for that, but you might have not used a loop. You may have just written 1 plus 2 plus 3 plus 4 plus 5, which is incorrect logic. It's not correct for the specification, and so you might still lose points on that. So validation is very, very important, and making sure that the logic of your program is correct, and writing sometimes your own tests to make sure that things are what you expect they are is also very important. Here is an example of some code from Lab 1 in Jupyter that we can take a look at together. So it's using this list analyze function, which is supposed to give the maximum, the minimum, the length, and the sum. And you can run that, and it would print out the information there. There are test cells at the bottom of most of the labs that are used in part for the validation and will sometimes be used for part of the grading. You can see that this one has some points assigned to it. And so we can check if the output that's given there is what you would expect. In this case, we provided what the output should be. For example, saying the maximum number in the list is 235 and so on. It's in this string here. This is a multi-line string. And that shows you what the output should be. And then what do you know? Your program actually provided that output. Now, an example of where this might run properly and pass validation is if you manually coded and said print the maximum number in the list is 235, and a new line that, or in another line that said print the minimum number in the list is negative 71, but you didn't actually analyze the list and you didn't find those from the data that was given to you, then yes, your code provided the output we expected, but it didn't do the job. It didn't follow the specification. And so be careful about actually following the specification. Not hard coding answers is what we would call that. If you have just looked at the answer and made your code only work for that exact answer and not actually do the job of, for instance, analyzing the list, then you will typically not get points for that because you didn't solve the problem, you didn't follow the specification. So yes, it's important to check that your output is the same as what's provided above, it's also still important to look back at your code, make sure you understand what it's doing, and make sure that it actually follows the specification. It doesn't just sort of cheat or skip steps to get the answer that's shown here, but not actually do the work of finding that answer. And that sort of brings us back around on all of our points there. It's important to understand what your code is doing so that you know that it follows the full specification. There will often be tests provided for you that you can use validate to run those. You sometimes will need to look at the output and make sure that the output matches what's expected for you too. And you may want to include some of your own tests as well. You can, in your own cell where you wrote list analyze, you could write a couple of tests for it there. Call it a few times with a list that was all zeros and make sure that it said the maximum was 0 and the minimum is 0 and the length and so on are all right. Then you would know that it handled a special case, and it would handle more and more cases the more you test it and the more you make sure that it follows the specification.